what we're going to do for the next little while. And quite frankly, this is super, super, super important for what we do in Integrated 2. So you really want to have this lesson down, or this section of the chapter down by the time we get to Integrated 2. Works on product versus sum. And what does that mean to say product versus sum? Well, you probably never really thought about this before. But if I add this up, I have 3, 6, 9, 12, right? And if I said, hey, I have 12 blocks, you wouldn't think that was weird at all because I just added them up. And again, sum means add. But I could have also said it as a product, and it would have been more unusual, but I could have said, oh, it's 3 times 4, right? 3 times 4 is the same as 12. So again, hey, Mr. Oliver, how many blocks do you have there? Oh, I have 12 blocks. That's if I said it as a sum. I just added together the middle. But I also could have said it as a product. How many blocks do you have? Oh, I have 3 times 4, right? That's how many blocks I have. 3 on the side times 4 on top. And that is the exact same as 12. And it might be odd if I said I had 3 times 4 blocks, but you would know I meant that I had 12 blocks. So it wouldn't be an incorrect way of saying it. And this is going to be something that we use for these shapes in Integrated 2. They're known as parabolas. So the way we describe these shapes, sometimes it's easier to describe it as a product, and sometimes it's easier to describe it as a sum. So this book in Integrated 1, what we're trying to do is lay the foundation for what comes up in Integrated 2. So, if this seems nonsensical and what are we counting blocks for or whatever, please realize it actually is very important for what's going to come next year. So having said that, we will go ahead and jump into 3, 2, 1. I just wanted to kind of throw that out there, that it is important and that it is going to go somewhere, especially next year. And that the product versus sum part of it is a big deal. So it says, obtain a set of algebra tiles for your team to use. The dimensions of some of the algebra tiles are shown to right. The algebra tiles will be named according to each of their areas. So hopefully you have some experience with these. This is known as an x squared because it's x times x. This is known as a y squared because it's y times y. This is known as an x because anything times 1 equals itself. So again, this is known as an x, this is known as an x squared, and this is known as a y squared. Just some of the names that have to do with that. And again, we have the distances that go around. So it says, use the algebra tiles to build polygons. Sketch the polygons on your paper. Label each tile on your sketch with its area. So first of all, the area is so much easier to get. This is just going to be a y squared plus x squared plus 1, right? Pretty simple. The perimeter is always a little bit tricky, right? I like to put a mark so I know where I start. So this length is y, this length is x, this length is x, this is 1, this is 1, this is 1. What am I going to call this? Well, this gets a little bit interesting. And I know some of you guys know this from junior high and some of you guys struggle with it. But the distance here is already x, right? Well, how much have I taken away from that x? I've taken 1 away. So think about it. What if this distance was 10 and I took 1 away? You would know it was 9 that was left, right? Or if this distance was 5 and I took 1 away, you would know that there was 4 left. Well, I don't know what the distance is, but I know it's 1 less than that. So not a huge deal. Hopefully you kind of conceptualize that. And in the same way, this distance, I have a distance of y, but you've taken x away from me. So this would be y minus x right here. This part, that doesn't look fabulous, so I'm going to have to go back and add these things in a minute. So let me say y minus x. This distance is y, and this distance is y. So my perimeter, I like to go alphabetical order. X plus x is 2x, plus x is 3x, minus an x, I'm back to 2x. So I have 2x. Y, I have 1, 2, 3, 4 y's. And ones, I have 1, 2, 3, minus 1. So 3 minus 1 is 2. So there's my perimeter, my area and my perimeter. Again, the area is always so much easier. I have an xy plus, these are y's, plus 3y plus x. I probably should have said plus x plus 3y. At this point, I'm not going to worry about any of it. So this distance, remember the short side is the x. This is just a 1, a 1, a 1. This part right here, I have a y minus, it's not y minus x because remember I'm only taking out this one part of it. So this is y minus 1. This is x, this is 1, this is x, this is 1, 1, 1. this part is x, and this part is y. And again, I hope you, if there's anything tricky here, it's y minus 1. And again, I've only subtracted a 1 from this whole y, not an x. By the way, if you think about it, what is y minus 1 plus 1? Well, you get y, and that's the original length anyway. So I have 1x, 2x's, 3x's, 4x's. I have 1y, 2 y's. And I have 1, 2, 3, minus 1 is 2, plus 1 is 3, 4, 5, 6. So that's going to be my perimeter. All right, moving on, it says use a group of algebra tiles shown here. So I'm going to use this E tool. I'm going to arrange these things in one large rectangle. By the way, this had nothing to do with the product and the sum that I talked about, right? Now we're going to move into that product and sum that I introduced the video with. So it says arrange the algebra tiles into one large rectangle with x squared tile in the lower left corner. I'm actually probably going to put it in the upper left corner. I prefer to start it in the upper left. Remember to flip so everything's positive. The area can be written again as the side times the side or the middle added together. So we're going to write it as the sum, and then we're going to write it as the product. Sorry, I had a big sneeze there. So this we're going to write it as the sum, and then we're going to write it as the product, and it says write the equation that shows that the area written as the sum is equivalent to the product. So this will be the product times the sum. So we'll jump over here. We have these algebra tiles. Like I said, I usually like to put the x squared on top left. And then what I do is, I think if you double click them, they turn. I like to go sort of in order, just to make sure that I haven't missed any opportunities. So clearly, if I were to do this, I'm not going to get a rectangle out of this, right? Like, when I go down and put these things in its shape, you can see that I clearly, by the way, these are meant to be so that the one doesn't line up perfectly. So, there we go. It doesn't work. So what I could do, I can move some of these out of the way, and I can drop one of these x's. And now we can see if it lines up, but it's still not lining up. So I'll drop a second one. And this one looks like I'll be closer. I don't know if this will actually get it or not, but I'm going to move these into position. So there we go. It did work out. I have my rectangle. And it has to be a rectangle. And what we talked about, and I can't write on this, but I have x plus 1, 2, 3, 4. And I have x plus 1, 2 going down the side. So I'm going to write this. I have x plus 4 and x plus 2. And if I write it as a sum, I have an x squared plus 1, 2, 3, 4, 5, 6 x's plus 8 ones. So I'm going to pause this and recreate this as good as I can over on the other sheet, but I want you to kind of remember this. I just can't write on this. Be told that this is not a perfect representation of what we had over here, but hopefully you agree it's like at least somewhat close. So it says the area of the rectangle can be written as the sum of the areas of all of its parts. Again, sum means I'm going to add up the middle. So I have an x squared. I have 1, 2, 3, 4, 5, 6 x's. And I have 1, 2, 3, 4, 5, 6, 7, 8 ones. It says the area can be written as the side lengths, right? So this is x plus 1 plus 1. So this side length is actually x plus 2. Again, there's an x, a 1, and a 1. This has an x, a 1, a 1, a 1, and a 1. So I can rewrite that as x plus 4. So I can also rewrite this as x plus 2 times x plus 4. Just like we could write 3 times 4 instead of 12, right? Again, this is our 12 here. This is our 3 times 4 from the beginning of the video example. If you didn't watch the beginning of the video and you're just skipping around and you have no idea what I'm talking about, that's what I'm talking about. But what we can say is, hey, look, these things equal each other. X plus 2 times x plus 4. X plus 2 times x plus 4 is the same as x squared plus 6x plus 8. Our product equals our sum, and it's just a different way of writing the same thing. By the way, I think this is kind of interesting. Let me pause this and go to Desmos and show you what I'm talking about. X squared plus 6x plus 8. I put it in, and you'll see we get this one parabola. Well, what if I put y equals x plus 2. Uh-oh, I didn't put plus 2. And then I put x plus 4. You can see I get the exact same parabola, right? Which is kind of interesting. So again, that's going to come in integrated 2. I'm not expecting you to know that right now. And I just want you to see that there is some value in what we're learning, that the product does equal the sum, that there are the same equation, and they do equal each other. All right, so let me set up the rest of this. What to do is take some algebra tiles and put these things into rectangle and write them as a product and a sum. So the first thing is these are already all written as a sum, right? So the product would be the part that we would need to focus on. So I'm just going to pick a few of these. I'm not going to do all of them. I'll do A. I will do D and E, and I will do H. So I've already kind of set up x squared plus 3x plus 2. So I have an x squared plus 3x plus 2 here. So kind of set this up, and again, I kind of like to go in order, and you can see that that's not going to get it done there. So let me drop one of these, and it looks like that'll get it. So I get x plus 2 and x plus 1. I hope you guys see that, right? Again, I already have this written as x squared plus 3x plus 2. I already have that part written. So I just need to say x plus 2 times x plus 1. And I'll be done with that one. So rather than have you watching me drag all this stuff around, I'll pause it and set up the next one. Y plus x plus y plus 1. So you can see there's my xy plus x plus y plus 1. This one, there's really only so many ways I can connect it, right? I can't connect the y to the x's. It's too big. So I'll turn this one sideways and set this up. And you can see I have y plus 1. Remember, the long side's y. The long side's y. So y plus 1 and x plus 1. So that's what I'll get here. Y plus 1, x plus 1. I will now go set up 2x squared plus 10x plus 12 and solve that one. I kind of regret picking this one as it is taking a lot of time to drag this stuff down, but obviously this doesn't work. So at that point, what I could do is start trying to make some different levels here and bring in some of these things down, and you can see that's not going to quite get it, but if I move a couple more, I might begin to be in better shape. So hopefully it looks like if I move these ones down, that'll line up pretty well. So there we go. So again, on this one, I have 1x, 2 x's, right? Plus 1, 2, 3, 4, 5, 6. So that's 2x plus 6 and x plus 2. So 2x plus 6 and x plus 2, so equals 2x plus 6 times x plus 2. And then finally, I will go ahead and set up 3x squared plus 4x plus 1. Squared plus 4x plus 1. These ones can be a little bit tricky, at least for me sometimes, so I'm not having a lot of luck with that. I don't know. Let's see. 3x squared plus 4x plus 1. Maybe I need to turn something sideways or something. There we go. That was the ticket. All right. So 3x plus 1 and x plus 1. So again, 1, 2, 3, x plus 1 and x plus 1 is what I'm going to get there. So equals 3x plus 1 times x plus 1. So you can see, again, I only did 4 of them. I typically don't make students do all of them in the class. Just play with some of it and get a feel for how this works. But again, just to see how important it is to have the product times a sum, because again, what is coming for you in integrated 2.